Example 8.9. So the question asks for the resultant torque of all the forces about rotation axis O in the following problem. Okay, so question asks for the resultant torque, right? So point O is the axis of rotation. Okay, I have transferred the free body diagram here. So the object here, the rigid body here is in rectangle. It has 10 meter times 6 meter size. There are three forces that acted on the rigid body. The first force is here, 30 Newton. The second force is here, 10 Newton, and the third force is 20 Newton here. We want to determine the resultant torque of this rigid body. Okay, so you know that formula of torque equal F cross D. Vector F cross vector D. Okay, D here is a distance from axis of rotation. Okay, so it's a cross product, right? So how to solve the cross product? You have learned this in chapter 1. Okay, so force and distance must be perpendicular to each other, and they produce torque that is also perpendicular to both F and D. For the first part, we will make force and distance perpendicular to each other. That is the first part. Then the second part is to determine direction of torque that is also perpendicular to F and D. Okay, so we start from force 1. Here is the direction of F1, 30 Newton. We can extend line of F1 here, the force. We can extend this line until it reach axis of rotation. Okay, axis of rotation is at point O. So here is the axis of rotation, which is 3 meter. And now you can look that F1 has been perpendicular to the axis of rotation, which is 3 meter. So torque of force 1, I call it as torque 1 equal the force is 30 times axis of rotation, which is 3. And it has been perpendicular, right? Remember, this is the cross product. Okay, so now is direction of torque. Okay, so here is the axis of rotation, and if one force pulling at this point, so how will be this square move? It will be moved clockwise or anti-clockwise? It will be moved clockwise. Okay, I think that maybe your lecturer will teach you and demonstrate it to you on how to determine direction of torque. Okay, you have to imagine that if you stick, you have a paper, a rectangular paper. You hold the paper onto the table at this point, and now at the end of the paper, at this point, you pull it to the right. So the paper will be moved, right? How was the motion of the paper? It will be moved clockwise. Okay, so clockwise is negative in direction. Generally, in physics, direction of to the left or direction of downward, physics decide that that direction is negative. For rotation, something that rotate, it's either rotate clockwise or rotate anti-clockwise. So how to determine direction, which one is a positive direction and which one is the negative direction? So in general, physics decide clockwise is negative direction. So this torque here is moving clockwise, so it has negative direction. The torque 1 is negative 90. Unit for torque is Newton meter. We move to the second torque from F2. Here is F2, 10 Newton at this point. Okay, so it is 10. And where is the distance from axis of rotation? Like I said, we can extend the line of forces until it reach axis of rotation. Okay, O is the axis of rotation. So here will be the axis of rotation, which is 5 meter. So it has been perpendicular to each other, so no need to resolve this force. Okay, so 10 times distance from axis of rotation is 5 meter. Okay, so here is the magnitude. How about direction? You can imagine that you hold the paper onto this point, and at this point, you will make it upward. You apply a force upward for a certain amount of force. So how will be the paper move? It will be moved anti-clockwise. So anti-clockwise is a positive or negative in direction. Anti-clockwise is a positive in direction. So you will get torque 2, which is 50 Newton meter. Okay, so now is torque from force 3. So we call it as torque 3. Okay, the amount of force is 20. Okay, we have to determine axis of rotation, right? Okay, we can extend this force until it reach point O. And where is the axis of rotation? It touch point O. So there is no distance from axis of rotation. Okay, so it will be times 0. So since it's times 0, so no need to find direction of this torque because torque 3 is 0 Newton meter. Okay, so question asks for the resultant force. Thus, we will sum all the 3 torque here, which is negative 90 plus 50 plus 0. So it will be negative 40 Newton meter. Okay, remember, torque is a vector quantity. It has magnitude and direction. So you have to state direction of torque as well. Okay, so because value of torque that we obtain is negative, so direction of torque is clockwise. Okay, we have done this question.